Hi everyone, my name is Anshu Kumar and I am one of the math experts from QMath. We are the #1 math experts community in India and we make learning mathematics fun. We at QMath enable our students to look for the why before the what of a concept, and all our students learn the concepts by themselves just by working on them. So I welcome you all to our channel, the NCERT Class 9 Math, where we will be posting videos on concepts and questions of different topics of this grade. So if you like this video, do share it with your friends. Do click on the like button. Do subscribe to our channel and also click on the bell icon. Also, if you want a live one-on-one session with one of the QMath certified teachers, do check the links in the description to enroll with QMath. And if you go and register with that link now, you're going to get one free live online demo session with us. So in today's video, let's learn how can we identify the zeros of a polynomial and how can we find the zeros of the polynomial. But before we proceed, you can go and check our previous video where we have made a video on the basics of polynomials, where you will be able to see like how can we identify a polynomial, how can we classify a polynomial, how can we find the degree of a polynomial. So you can go and check that and then come back to proceed with this video. Now let us first try and understand what do we mean by the zeros of a polynomial. But to understand this, let's first know what is the value of a polynomial. So basically the value of a polynomial is any value the polynomial will have based on the values of its variable. For example, let us take a polynomial which is p of x equals x squared minus 2x plus 3. Now this polynomial p of x depends on its variable x. So let us consider three values for this variable. If x is equal to 0, x is equal to 1, and x is equal to 3. Now if x is equal to 0, p of x becomes p of 0. Let's substitute 0 in place of x in this polynomial. So we are going to get p of 0 is equal to 0 squared minus twice 0 plus 3. If we solve this part, we are going to get 3. So if the value of the variable is 0, the value of the polynomial is 3. Similarly, if we substitute x is equal to 1, p of 1 equals 1 squared minus twice of 1 plus 3. If we evaluate this part, we are going to get 2. So if x is 1, the value of the polynomial is 2. Similarly, if x is 3, p of 3 equals 3 squared minus twice of 3 plus 3. If we evaluate this part, we are going to get 6. So if the value of the variable x is 3, the value of the polynomial p of x is 6. So we see that how with the different values of the variable, there is a change in the value of the polynomial as well. Now let's look at a few questions of how can we use this concept to find the values of the polynomial. So here we have been given a polynomial f of y equals 3y cubed minus 2y squared plus 7y minus 8, and we'll have to find the value of this polynomial at y is equal to 2. Now let's evaluate this polynomial by substituting y as 2. So in place of y, we'll write 2. So f of 2 equals 3. In place of y cube, we'll have 2 cube minus twice of 2 square plus 7 times 2 minus 8. If we evaluate this further, we are going to get 8 times 3, that is 24, minus 2 to the 4 to the 8, plus 7 to the 14, minus 8. Now if we add the two positive numbers, we are going to get 38. And if we add the two negative numbers, we are going to get 16, which is going to give us the value of the polynomial to be 22. Hence, we see that if the value of the variable is 2, the value of the polynomial is 22. Let's look at the next question. So here we have the next question where we'll have to find the value of this expression p of 2 minus p of minus 1 if p of t equals 1 plus 5t minus t square. So we'll have to evaluate this question in parts. So the first part would be if we find the value of p of 2 by substituting t as 2. So if t is equal to 2, this polynomial becomes 1 plus 5 times 2 minus 2 square And if we evaluate this, we are going to get 1 plus 10 minus 4, which is going to get 11 minus 4, that is equal to 7. Now let's solve the next part where we'll have to find the value of p of minus 1. It means that we'll have to substitute in place of t -1. So that is going to make this polynomial 1 plus 5 times -1 negative t square. So t square is -1 square. If we evaluate this part, we are going to get 1. 5 times -1 is -5 minus -1 square is -1. So we do have a positive 1 and a -1. So these two will cross out and eventually the result would be -5. Now we have the value of p of 2. We have the value of p of -1. If we substitute these two in this expression, in this question, where we have the question to be p of 2 minus p of -1. If we evaluate this part by substituting the values, so p of 2 is 7 minus -5. If you open the brackets, we are going to get negative will become positive. So 7 plus 5, which is going to give us 12. Now we see that for different values of the variable, we got different values of the polynomial, and we can then use that result to solve any combination of the question, which we saw here as well. So based on the questions which we have just solved, we just saw what do we mean by the value of the polynomial. Now we'll extend this argument to get to the 0 of a polynomial, where the 0 of the polynomial is that value of the variable for which the value of the polynomial is 0. For example, if we consider a polynomial p of x equals 2x minus 3, we'll have to find the value of the variable x for which the value of the whole polynomial is going to be equal to 0. So it means that p of x should be equal to 0. So if p of x is equal to 0, in place of p of x, we can substitute the polynomial, which is 2x minus 3. So the equation would be 2x minus 3 equal to 0. If we solve this, rearranging the terms, we are going to get x is equal to 3 over 2. So basically, x is equal to 3 over 2 is that value of the variable for which the polynomial p of x is equal to 2x minus 3. We can verify this as well. In place of x in the polynomial, let's substitute 3 over 2. So p of 3 over 2 equals twice of 3 over 2 minus 3. Now 2 gets cancelled. So 3 minus 3 equals 0. So this is how we can find the 0 of a polynomial, and we can also identify the 0 of a polynomial. Let's take one more polynomial as an example, where we have q of y equals negative square root of 5y plus square root of 3. Again, we'll have to find the value of the variable y for which the polynomial q of y equals 0. For that, q of y equals 0, or in place of q of y, we can substitute negative square root of 5y plus square root of 3 equals 0. Rearranging the terms, we get y equals square root of 3 over square root of 5. Now you all can verify this value, like substitute this value in the polynomial and check for yourself whether for this value of the variable, the value of the polynomial q of y is equal to 0 or not. Let's now work on some questions based on this concept. So basically, we do have a question here where we have been given 4 options, and we'll have to check which of these following are the zeros of this polynomial h of x equals to x square minus 6x plus 4. Now let's substitute each of these options to check which of these options are the zeros. So let's take the first one. It's given x equals 1. So in place of x, we are going to substitute 1. So h of 1 equals twice of 1 square minus 6 times 1 plus 4. If we simplify this further, we are going to get twice of 1 square is nothing but 2 minus 6 plus 4. Adding the positive numbers, we are going to get 6. So 6 minus 6 is equal to 0. It means that this first option is definitely a 0 of this polynomial, because when we substitute this value of the variable in the polynomial becomes 0. Let's check for the second option, x is equal to 2. So in place of x, we are going to now substitute 2. So h of 2 equals twice of 2 square minus 6 times 2 plus 4, and this is equal to, so basically twice of 2 square is nothing but twice of 4, which is 8, minus 6 2s are 12, plus 4. Again we add the positive numbers, we are going to get 12 minus 12 is equal to 0. Hence this is also one of the zeros of this polynomial. Let's now check for the third option, x is equal to 3. In place of x, we are going to substitute 3. So h of 3 equals twice of 3 square minus 6 times 3 plus 4. So twice of 3 square is nothing but twice of 9, which is 18. So 18 minus 18 plus 4 is going to give us 4, because 18 minus 18 is 0. 0 plus 4 is 4. So here we got 4 as the result. Hence, we can say that this is not the zero of this polynomial. Let's check for the last option where x is 4. So in place of x, we are going to substitute 4. So h of 4 equals twice of 4 square minus 6 times 4 plus 4. Now, if we evaluate this part, twice of 4 square basically means twice of 16, which is 32. 32 minus 6 times 4 is 24 plus 4. So 32 plus 4 is 36. 36 minus 12 is, 36 minus 24 is 12. And hence we didn't get a 0 as the result of this polynomial. Hence we can say that x is equal to 4 is not the zero of this polynomial. So you saw how easily by substituting the values of the variables we can determine whether that particular value is the zero of the polynomial or not. Let's now work on the next question. So here we have the next question where we have 3 polynomials and we'll have to verify whether the following are zeros of the polynomials indicated against them. So for example, for the first polynomial p of x equals lx plus m, we'll have to check whether x equals negative m over l is a zero of this polynomial p of x or not. Now to check for that, let's, in place of x, let's substitute negative m over l. Now once we do this, the polynomial becomes, now in place of x, we are going to substitute negative m over l. So this is L times negative m over L plus m. If we simplify this further, we basically get negative ml over L plus m. Now, if we eliminate the common factors, we are going to cross out these two L's, and eventually we are going to get negative m plus m, which is 0. So the result of the polynomial is 0 when we substituted the value of the variable. It means that this x is a 0 of this given polynomial p of x. Let's now check for the second polynomial p of x, where p of x equals 3x square minus x, and there are 2 values of the variable given. Let's check for both. So let's first check for the first one, where we have, in place of x, we'll substitute negative 1 over square root of 3. So basically the polynomial becomes 3 times negative 1 over square root of 3 whole square minus 1, which is equal to 3 times. Now negative 1 over square root of 3 square would be, now negative square is positive. 1 over square root of 3 square is 1 over 3 minus 1. So again, let's eliminate the common factors. 3 and 3 gone, which would result in 1 minus 1, which is 0. So we can say that this value of the variable is the 0 of this polynomial p of x. Let's check whether the second value given here is the value of the, is the 0 of the polynomial or not. So in place of x, we are going to substitute now 2 over square root of 3, which is going to give us 3 times 2 over square root of 3 square minus 1, which is going to be equal to 3 times 4 over 3 minus 1, And once we eliminate the common factors, we are going to get 4 minus 1. So 4 minus 1 is nothing but 3. Since we are not getting a 0 here, so the value of the variable 2 over square root of 3 is not the 0 of the polynomial p of x. So we can cross this out. Let's now check for the last polynomial, which is p of x equals 5x minus pi. And we'll have to check for the value of the variable x equals 4 over 5. So in place of x, we are going to substitute 4 over 5. So p of 4 over 5 equals 5 times 4 over 5 minus pi. And we eliminate the common factors. We are going to get 4 minus pi here. Now 4 minus pi will not give us a 0. Hence, the value of the variable x equals 4 over 5 when substituted in the polynomial p of x equals 5x minus pi will not give us a 0. So this is not the 0 of the given polynomial. Hence, we'll cross this out as well. Now, this is the different methods through which, if we are given the zeros, we can substitute them in place of the variable and we can verify whether they are the zeros of the polynomials or not. So basically, this is it for this video. So we hope that you have understood how can you identify and find the zeros of the polynomial. You can try these methods and solve questions given in your textbook. Do ask us if you have any doubts, any questions in the comment section below. We will be very happy to answer all of them. If you like this video, do share it with your friends. Click on the like button. Do subscribe to our channel and also click on the bell icon. Also, remember, if you want a live one-on-one session with one of the QMath certified teachers, you can check the links in the description to enroll with QMath, and you go and register now. You're going to get one free live online demo session with us. So do have a good day and goodbye for now.